So the next part is to go ahead and take a look at both of these graphs, and if you look at them, you should be able to make some observations, or what we would normally say is, what do you notice about them? So go ahead and take a moment to do that. If you need to, pause the video and go ahead and write those down. You could go ahead and put them below here about what you notice in bulleted points, but go ahead and pause the video and do that. So some things you should notice based off of all the graphing we've done is, if you look at your quadrant, we're still in the first quadrant on both of these, and if you look at your x and y axis, you should be able to see that the x-axis here is pesos as to where the x-axis here is dollars, and the y-axis here is dollars, and the y-axis here is pesos. So basically, these graphs are flipped around, they're inverted from each other. So they've just changed their x and y axis. But when you do that, you'll notice that the graph also changes in the slope as well as the ordered pairs. So those are some observations you should notice, as well as when you're looking at the set of ordered pairs here, where you're looking at 9,660 pesos, you are looking at $500, where if you are looking at $500 here, you're actually looking at $9,660. So it's basically just changing your function format as to what's operating as the function of what. So we're going to continue looking at some inverse functions here, and we basically have some cookbooks that are being compared for online stores, which is the way to go if you're going to try to price compare and beat other businesses to see, and if you can't find it at your local brick and mortar store. Not trying to support online over brick and mortar, but you know, it is better sometimes. So if we go ahead and look at number 5, basically Lynn's going to compare the cost of buying cookbooks here at the different stores. So we have store A that sells them at $9 and offers free shipping. B sells them at $9. It looks like we're talking cursive here again. Sells them at $9 each and charges $5 for shipping. C sells them at P dollars and charges $5 for shipping. D sells them at P dollars and charges F dollar for shipping. So your job is, after looking at all of these, is to go ahead and see if you can write an equation that's going to represent your total cost, that's going to be defined by the variable T in dollars as a function of the number of cookbooks that are bought, number of cookbooks being represented by N at each store. So pause the video and go ahead and do that. So I would hope you were pausing that and not just waiting for that moment where I'm just going to give you the answer anyhow, because that would be pointless and useless and doesn't help your brain work. But if you did not pause it, I guess you're ready to move along anyhow. So we're supposed to be able to actually create the equation, and so you basically would have needed to write 4 different equations that represents each of these different stores. So for the first one, we should have where store A is going to have the equation that the total represented by T is equal to, and again, these are equations, and yes, we can treat them as input-output, but we're not writing them in function format right now, is equal to the $9 per cookbook for the number of cookbooks. And store B sells them at $9 each, so the total is going to be equivalent to $9 each. So 9 times the N, with an additional $5 cost in shipping. I would hope that when you're looking at this, you could make an inference as to whether or not this would qualify as if it would pass through point of origin, that kind of stuff, and kind of relate some slope as you're looking at some of these formats. And then for letter C, for the SAT story, we would have where we don't know, except it's in the P format, P dollars per the number of cookbooks, but an additional $5 shipping. And then store D sells them at P number of cookbooks, the price for the number of cookbooks, and an additional unknown shipping charge, where they have presented it with the variable F instead of S for shipping, but that's okay. So those are the 4 equations that you would need to represent each of those for each of those situations. So the second thing asks us to write an equation to find the number of books that are represented by N, again, that Lynn could buy if she spent T dollars at each store. So this is basically wanting us to take and relate back to each of these, but finding the inverse operation pretty much, or the inverse function that represents that. So again, you're going to do that for letter A. or store A, store B, store C, and store D. So go ahead and pause the video and do that. So, unpausing the video, I hope, and not just waiting for my marvelous answers. The first one would have been that T is equal to the 9 times the N, the number of cookbooks. And so we can go ahead and basically manipulate the equation to solve for N. And so we would use the division property of equality where we divide each side by N so that we have the total is being divided by 9 and is equal to N. So that is the equation that is going to represent store A. That's the inverse. And then similar process for store B, where we would have that T is equal to 9 and plus 5. So we're going to subtract that first. Subtract it? My brain stopped working. Yeah, we have to subtract it. Inverse operation. And that's not connected to the variable. Subtract 5 from both sides, so now we have T minus 5 is equal to 9n. And we want to solve for n, essentially. And so when we do that, we're going to use the division property of equality, so divide each side by 9. And so this side then becomes T minus 5 over 9 is equal to n. So this is the inverse operation for store B. If you'll notice, the steps are shown here, and it really didn't take me that much time to write them. So then for store C, we have T is equal to P times N plus 5, and we're doing the same thing. We're going to solve for N, so we're going to subtract the 5, so we have T minus 5 from both sides is equal to P times N, and then we need to use the division property of equality to solve for N, where we have N is equal to T minus 5 being divided by P as well. And that is the function that resembles switching the function pretty much so that it's the equation to find the number of books that she could buy if she spent total T dollars. And then that leaves letter D finally, store D I should say, which is in the format of T is equal to P times N plus F. And now there's a lot of letters, so people that are weirded out by using that many letters might have a little bit of struggle with this one. And that's okay, because a lot of people's brains don't like to think of it as we're just treating it like we would numbers. We're going to go ahead and subtract the thing that's not related to the variable here using the inverse operation. So we're going to use the subtraction property of equality, and we're going to do that to both sides of the equation, which gives us the P, T minus F is equal to P times N, and then we are trying to find for the number of cookbooks, so we're going to divide by P on both sides, and that gives me a variable of N on this side where T minus F is being divided by P. So those are the 4 equations that are needed by finding the inverse equation of the previous situation by switching what the function would be based on the situation. So one was the function for the total cost, and the other one is for the total number of cookbooks.